Asked about sheet number 1. I had a student who asked about how, if I can show how to get examples of how to do ones where there's 2 and 3 on one, like there's 2 on one side and 3 on the other, for the number of subscripts, and also to do an example with parentheses. So I'm going to do that. We're going to do number 2 and number 11 as an example. So first take a look at number 2 so I can show you what's going on. Notice that the FE on this side here, okay, there we go. There we go. FE on this side, there's only one of them, but there's 2 over on the left-hand side. So if I put a 2 here, I recognize that I may have to change this, but at least now I have the FEs balanced, okay? So I have 2 FEs on the left-hand side and 2 on the right-hand side because of that subscript 2. Now notice that the oxygen has a 2 on this side, on the left-hand side, and a 3 on the right-hand side. Now, here is how I do this. I treat it like I am adding fractions. I don't know if you remember how to add fractions of different denominators, but we have to get the lowest common denominator. The lowest common denominator for 1/2 and 1/3 is, of course, 6. Okay, so that turns my 1/2 into 3/6, because that's the same as 1/2, and that turns my 1/3 into 2/6, because that's the same as 1/3. And then I add them together like that, and that's how I do it. The important part being that I find a number that's common to both of them. Okay, so I'm going to erase this, even though a lot of what we do in chemistry kind of works like fractions, but I'm going to erase that part there to show you this. If I put a 3 over here, that gives me 6 oxygens. If I put a 2 in front here, 2 times 3 gives me 6 oxygens. And now I have the same number of oxygens on both sides. So the problem is that once I put the 2 in front of the compound, and you always put coefficients in front of the compound, don't try and squeeze them in like that. I've seen students try to do that before. You must put it in front of the whole compound, which means 2 times 2 here gives me 4 FEs, right? But over here, I only have 2. So I go back and erase this 2 and put a 4 here. And now I have 4 FEs on this side. So now I have 4 FEs on both sides, and I have 6 oxygens on both sides. So whenever there's a 2 on one side and a 3 on the other, I just simply multiply 1 by 2 and 1 by 3 to get the same number of total oxygens on both sides. I see something that looks like that here, down here, but notice that I have oxygen here and I have it here in this compound. So I have oxygen in 2 different places, so this one doesn't quite work like that, but I know that I've done this one as an example before. So let's jump ahead to 11. And you can see one that has parentheses. Here's parentheses over here. The parentheses are for NO3, a polyatomic ion. Notice the 2 on the outside means I have 2 NO3s on the right-hand side. Okay, that's great. How many do I have over here? On the left-hand side, I do not have 3 NOs. I have only 1 NO3. The NO3 stays together as one single unit. And if I were to put parentheses here, I knew that was going to happen. I knew it was going to screw up. And if I had to put parentheses here, I would put a number 1 on the outside. Okay, so the parentheses NO3 and O1 means there's only 1 NO3 there. Okay, so these polyatomic ions are very deceiving. That 3 right here looks like it means there's 3 NOs. And that looks like it might be different than something else, and it's not. It's the same NO3. There's only 1 of them, though. So if I have 2 NO3s on the right-hand side and only 1 on the left-hand side, I have to put a 2 in front. Now I have 2 times 1 gives me 2 NO3s. So that now works, and I'm balanced with the NO3s, but I'm not balanced with the AGs. How many AGs do I have on the right-hand side? I only have 1 because there's no number in front and there's no subscript. So that means I need a 2 in front of the AGs there. Now let's go back and check. I have 1 CU here and 1 CU here because there's no number there. Now I have 2 AGs here and 2 over here because I put the coefficients in front. I have 2 NO3s here, and I already have 2 NO3s there. So that does actually work. Excellent. I'm feeling generous. Let's do one more example with parentheses. And here's one, number 17. Number 17 has two compounds that have parentheses. So let's see what we got. I got Al on the left-hand side, and there's only one there. I have two aluminums on the right-hand side because of the two right there. So I go back and I put a 2 in front. Now that means I have two aluminums, but it also means I have 2 times 3 is 6 NO3s. Okay, that's important because on the right-hand side, how many NO3s do I have? I do not have 3 NOs. I have only one NO3 because if there were more than one, I would have parentheses and a number on the outside. So that means I have only, come on, where's my eraser? That means I only have one NO3 there, and to get 6, I need to put a 6 in front of the whole compound. So now I have 6 hydrogens over here. 6 times 1 gives me 6 hydrogens. What number times 2 would give me 6 hydrogens on this side? Well, as it turns out, a 3 times 2 equals 6 hydrogens, and then that balances the hydrogens on both sides. That gives me 3 SO4s, because I only have one SO4 in the formula, but I put a 3 in front, and now I have 3. Look how well that worked out. I have 3 on this side over here. So now I have a compound or equation that says 2, 3, 1, 6. Okay, so you may see answers given like this, 2, 3, 1, 6, like that. And that's just showing you the numbers that show up in front. I hope that really helped. I hope that helps clear up some. We can practice more balancing. If you're still struggling with it, I can give you a bonus sheet. That's sheet number 2. But I skip over that to do sheet number 3, which is something a little bit different. But if you would like sheet number 2, I can definitely post it and give you maybe bonus points for completing that and practicing your balancing. Thanks for tuning in.